Okay, it looks like we're getting started very shortly. Just checking that my audio works and that everyone can hear me. Okay. Just a few moments to see if anyone else is joining before we get started. Okay, I guess we'll jump on into it. So today's webinar or live stream is going to be about Mqtt, particularly focusing on the WiPy, talking about how we can do low bandwidth, low latency messaging over Wi-Fi over the internet, looking at the Mqtt protocol in specific, talking about why you might use this with your projects and the kind of methodology involved around sending, receiving, which are known as publishing and subscribing to Mqtt. So we're going to look a little bit about Mqtt to start with, explain what the technology is, what the protocol is, why you won't use it, some examples of where it's being used currently, and then look into a little bit about how you can start creating your own Mqtt messages, setting up a broker, and then getting messages being sent backwards and forwards. So I'm going to touch on a couple of topics. I'm going to look at a couple of different brokers as well. I'm going to look at just a couple of test brokers. So there's test.mosquito.org, which is a free public broker you can use to test your Mqtt. This is pretty simple, pretty straightforward. There's also Adafruit's io.adafruit.com, which is a I think it's in beta right now, but you can sign up for it and access to their tool, which allows you to visualize your data and see what's coming in and coming out from your data streams. So as well as this, I'm going to also do an example where you can host your own broker on your own machine, and this gives you a nice easy way of testing sending and receiving data locally. So if there's any issues with hearing me or anything else, do let me know in the live chat. Also, feel free to ask questions and comment if there's any concerns or miscommunication about anything I've said. Stop me as I'm talking, don't wait till the end, otherwise I might find it hard to backtrack and work out where exactly the confusion was taking place. So let's get started and have a quick look at Mqtt. So I'm going to jump over to Chrome quickly and have a look at what the Mqtt website says. So Mqtt is a standard. Mqtt stands for MQ Telemetry Transport. It's a methodology based around publishing, subscribing. So you can imagine this is like a forum. So you can publish posts and you can also subscribe to specific threads. So when you publish to a thread, everyone in that thread who's listening gets a notification, which is the equivalent of subscribing. This is somewhat different to doing like an HTTP request, sending data to a server, and the server receiving it. Basically, it's like having an ear listening constantly for anything that's coming. The idea is that you can have a small ping that just says, hey, I'm still listening on the end of this subscribe end, and that whenever data comes and receives on that end, then it gets sent to a specific device. So you can use the WiPy, in this case, as a bidirectional device. You can both subscribe and publish data. And the idea with Mqtt is that it's supposed to be low bandwidth and low latency, so you can send a lot of messages very quickly without worry that there'll be any collision or congestion of trying to send your data. So I had a couple of links on some comments that were in the forum post. So we'll talk about those in a bit, but I'm going to put them up here quickly so you can have a look at them if you're following along. I'll also post this in the forum post afterwards so you can find out what I've been talking about. So really quickly, this post here is about how fast can you publish messages. This is an interesting post, I think, from Robin in the forums. Yeah, Rob Mark Cole in the forums, who asked about how fast can you publish MQTT messages, and you've got a couple of other questions, Robin, so I'm going to answer those in a second. But this post I found earlier today was particularly interesting. So this talks about using a Raspberry Pi to actually send the MQTT messages, and it's very much a similar case with the WiPy as well. The biggest factors that determine how fast you can send and receive messages actually have to do with one, the quality of service, which is a QoS specified by your device, and then also the network connection, and then finally the processing power of the device itself. So generally, I mean, I'm not sure what your use case is or your intention for the bandwidth of the channel, but you can actually send a lot of messages very, very quickly in a very short period of time. So looking at this Raspberry Pi 2 table, and this is using a MQTT client based on the Peiho variant, which is a version of the MQTT client. And this is running on the Raspberry Pi. You can see this table here. They've got a number of messages being sent, and then how long in milliseconds it takes to receive all of these, and then the quality of service between 0 and quality of service 2. So I'll quickly explain what the difference between the quality of service is. Basically, if you've got the QoS set to 0, whenever you send a message over MQTT, there is no acknowledge required to receive that message. So the idea is that if you send a message, you don't actually know whether that message has successfully arrived at its destination. So your WiPy might have sent a message, and then there's a broker listening for those messages. With QoS set to 2, the WiPy would expect to have the broker send a message back to it saying, "Hey, look, I've received the data you sent." If you set the QoS to 0, it doesn't do this acknowledge protocol. It simply just sends the messages nonstop, and you're kind of left hoping that they will make it through. So it's a trade-off. You can choose to either have the quality of service guaranteed or the quality of service not ensured, and then have a increased rate of transmission. So here they've got it running on the Raspberry Pi 2, and they're getting about 26 milliseconds of delay between sending one message to server. And this is a little bit of a there's a lot of variables involved with the numbers they're coming up with here. So we don't know what kind of network they're sending this over. We don't know anything about their where the broker is hosted between the device and itself, whether that's on the same network, whether that's remotely. Actually, okay, so they said it here, it's on an AWS instance. So it should be quite a fast uplink to the server, but we don't know anything about their specific home network or their office network. So there's a lot of factors involved with how fast these messages can actually get through to the server. But you can see for the time it takes to send one message in 26 microseconds, sorry, milliseconds even, that's pretty substantial. And you start scaling this up to 10,000, it only takes 3.9 seconds, which is pretty incredible as well. So it's, unless you're doing incredibly fast processing, you're not going to run into any upper bound with limitations with MQTT. But again, if you want to test these out specifically, I'm sure at some point when I get through my long checklist of Alex's Corners and other events that we need to get planned, I'll try and do a benchmark and see how fast we can actually ping these messages through. But if anyone comes up with that before me, I'd love to see some examples. So do let me know if you come across that. Okay, so that's answered your bandwidth question. There's another question regarding security. So let me quickly run back and see what the question there was. So authentication. So this is an interesting one. So the way that I've handled authentication on my application is I've just had two separate files, your main.py, which is where all of your functionality will run, and then a config.py file. Let me jump over quickly to my Atom to show you this. Okay. Ooh. Okay, cool. So you can see here on the left-hand side, I've got config file and main.py. What I normally do is I just keep that separate, so when I'm doing my live streams, no one can see any of my username, password stuff. This is all fine on the device. This isn't shared anywhere other than on the device itself. So obviously, if you have access to the device, you could put it into safe boot mode and get access to the files that way. I believe we have a method coming where you can add a password to the safe boot mode, so to prevent anyone from actually getting access to your files. So this will be coming in the future at some point. But for the time being, the best way of doing it is having two separate files, just so that you know that whenever you're sharing your code online or whatever, you can keep your keys and everything private. The question about passwords being encrypted over the network, this really depends on what kind of broker you're talking to. So there's a number of different brokers that are available. Some of them have encrypted sockets, some of them use encrypted web sockets, some of them use TLS, some of them use a whole variety of different web protocols for connecting your MQTT endpoints over. And really, it's up to you as to whether you choose to go for an encrypted solution. I mean, if you head over to test.mosquito.org, let's get back up to my Chrome. You can see that they've got a couple of example endpoints with encrypted sockets as well. So yeah, here we go. They've got a couple of different ports open with various different connection protocols. So if you connect to port 1883, you'll have an unencrypted socket. If you connect to 8883, you'll have an encrypted socket, so on and so forth. Some of them you can specify a client certificate's required. You can actually set this within the Mqtt library that's in our GitHub repo. Again, I'll link this up after I've done the post, because I realize there's some confusion as to which library I'm referring to when I'm talking about the Mqtt. And then you can also do it over WebSockets, which I don't think the library currently supports, but this is something we can look at adding in the future. But the first three I know are definitely supported because I've tested them all this morning. The latter two may need some changes to the library before they work. But while I'm talking about the library, let's go have a look at that. So this is under github.com/pycom/Pycom libraries. And this is the library that I'm referring to when I'm doing my demo here and any of the documentation that I push online. I acknowledge that the documentation we currently have available at docs.pycom.io is currently not aligned with this, and it's using an older micropython.org version of the Mqtt libraries. So after I finish this live stream, I'm going to go ahead and actually update that and make sure that's in line with everything else I've been speaking about. So let's jump at the examples. You can see a bunch of our examples, and then let's have a look at MQTT. So the MQTT library is basically just a mqtt.py file. You've got the class for the client. You can see the initialization parameters, and then all the different functions, different methods that are based off of that. And we can see an example in my code actually where I'm utilizing this, and it might make a bit more sense if we jump into an example. So let's get Atom back up again. Okay, so let's make this a bit bigger. So I've done a couple of little tricks here, but you don't need to do some of them. So one of the things I've done in my code is I've added a kind of a fake interrupt, just to let me be able to break out of the loop if I wanted to reprogram or test any code. So just ignore this machine.pin. This is just to let me quickly debug. So what we first of all start doing is we grab the MQTT library from the MQTT client class from the MQTT library. And you can see on the left here, under lib, we have that library file. So this is effectively what my file directory on my board looks like. I have my main.py, my config.py, my boot.py, and then in my lib folder I have the MQTT library. So first of all, import that. Then I import my config file, and then import time, which I'm just using to sleep the device. So these two parameters, the set timeout is just to say how long the MQTT client will try to connect to the server before failing. And then we have a callback, which is set to say if a message appears on the topic, then trigger this callback. So when I say topic, the way that MQTT works is you have the broker, which is then divided up into a number of topics. And these topics you can imagine are like forum threads. So if I were to go to forums.pycom.io, create a thread, that would be effectively what you imagine as a topic. So every time I posted within that thread, that would be publishing to the thread or the topic. And every time that someone else posts to that topic, that's known as subscribing. So I'll get a notification when that happens. And that's the easiest way to kind of imagine or to think about the MQTT protocol. So next, I create a client object from the MQTT library that we imported earlier. I'm grabbing a couple of config details from my config file. So obviously I'm going to keep those private because the Adafruit server that I'm using has my private API keys, and I don't want to expose that to the internet because someone will abuse my account and probably exceed my API calls for the day, which means I'd have to reset my keys and so on and so forth. So those are simply just strings set within my config file. It's basically client ID is equal to anything you want. This is user configurable. This is just the name of your device, so that it's like your username on the forum, so someone can identify who's posting. Then you've got the server address. So this is io.adafruit.com or test.mosquito.org or your local MQTT server. It could be whatever you wanted. Then we've got my username, password, and then the port that I'm connecting to. So we could just use a quick example of a non-encrypted open, no username, no password version. So we'll quickly uncomment the test.mosquito broker. So this is a broker running at this address, and we're going to connect to it with a device known as WiPy at the port 1883. Then we set our timeout, which is just the duration here. So we're just saying keep going until forever, basically. We then set our callback, subscription callback. So this is what happens when a message appears in the topic and we have a subscription callback triggered. Then we run our connect method, which says, okay, take my connection details and then connect my WiPy up to the broker. Then we're just publishing some data to that topic to specify it here with the message false. Could be anything you want to. Could be a string, could be a boolean, could be whatever you want to. I believe you have to send it up as a string though, so make sure you convert it to a string before you send it. Then we're just going to sleep for a little bit, and then we're doing a subscription to that feed to say, hey, has anything appeared on that feed? If so, then we know to do the client.check message, which says check the subscribed topic, and if anything's appeared, then trigger the callback on the subscription. So that's all well and good, and then we need to run a loop just to make sure that we're continuously checking the client to see if any messages have appeared. So this is where my little machine import of the pin comes in. I'm using I'll get my hovercam back up again. I'm using a expansion board here, and basically using the button on the expansion board to break out of the loop if I wanted to go back to the REPL. So what happens here is, whilst the pin is high, my client checks the message and then goes to sleep. If pin isn't high, if I'm pressing the button, it breaks out this while loop and then finishes executing the main.py file. So let's quickly save this. And let's go back to Atom quickly. So you may have noticed something interesting. I now have this Pycom console down the bottom. So today we've just announced and released our Atom plugin. So this is our brand new Atom plugin. Let me put the wrong port. There's some more information about this just come out in the forums. Also, if you check out our documentation, it should have been updated to come in line with this. So let me just check quickly, make sure I've got the right device here. And we'll be using this to upload files to the board and connect, etc., etc. So I quickly got to change the device address. So we've got the new device, connect to it. Okay, now we've booted into our, we've connected to our device serial. So this works like you'd expect it to. Hello world. And now you've got your standard REPL open again. So let's jump back into the main.py file, and you can see now we've got our script all set and ready to go, and then we can quickly press run, and it should run this on our board now, which is quite cool. So what we're doing now is we're opening our connection string, and we should see in a second it come up with client.connect, where it tells us connect to the broker if it's succeeded. I've had some issues today with Mosquito taking quite a while to connect, so it may take a few seconds before it actually connects to Mosquito, and then it'll let us know that that connection's been made and then published to this specific feed that we specified. So just give it a couple of seconds. Yep, there you go. So it connected to the broker, and then published my message, which was false. So we should see in a couple seconds when it wakes up from the sleep, it subscribes to that topic, and then prints out our message. Wait, checks for the message, or maybe not. So one of the interesting things about MQTT, which actually was the last question of Robin's that I was going to get around to answering, which was, can you retrieve messages that are published whilst the device is asleep? And so this is why I did the sleep function, like why I called the sleep function here, was to actually demonstrate this. So this depends on the type of MQTT broker you're using. And actually, if you've got control over it, you can specify flags which say, hey, any device that connects to or subscribes to a topic and does a message check, if it's been asleep and does a new subscribe, then give it the last message it was sent. So what it looks like is that on the test.mosquito.org broker, they don't currently have the flag set for doing the new connection or last message sent back to the device. I believe this is set up, however, for the Adafruit broker. So what happens is when you post to it and then go to sleep and you wake up again and subscribe, every time you do that subscribe and check for a message for the first time, it gives you back the last message that was sent to that broker. So if I quickly just stop this running, go and comment out this, and then uncomment this, save that, and then run it again. So we now just connected to my Adafruit, io.adafruit.com, published a message to it, and now we're going to quickly subscribe again in a couple of seconds, and it should give us back the last message that's published. Yeah, so there we go. So we got false, which was published earlier. And this is dependent on your broker. So it really depends on if you have control of your broker and you can specify these flags, then you'll have control over whether or not you'll be able to get the last message upon subscription. I'm seeing some compliments about the plugin. Yes, I'm super pleased with the plugin. It's looking really nice now, and it's actually really, really easy to use. Works particularly nicely for me because my workflow is based around Atoms. We will have other support for other editors and IDEs coming in the future. Okay, so yeah, so that's an example of connecting to the broker, publishing, subscribing, and seeing our last message. So in case you're wondering if I have this pre-built and I've already made this project, I'm going to create a different message. So let's change this to hello Pycom community, and then we'll save that and run it again. So connected to the broker, we should have published hello Pycom community, and then we'll see in a second that message come back. So we've sent it to sleep for 10 seconds, and it should wake up again, and hello Pycom community. So that's gone to Adafruit servers. We've published it to Adafruit servers under the topic bucknell/feeds/lights. Could be anything. You can name your feeds. If you go to io.adafruit.com, there's a whole interface for setting up your different topics and different data visualizations. Maybe we'll look at that another day, but I've done a Hackster.io project that talks about using that for data visualization. So I might link that as well, so you can have a look at that project. But that goes up to Adafruit, and then we subscribe to it, and we get back our message. So one of the other things that we can do is if we go back to Chrome now, let's jump back into Chrome. So I was going to post another message from another device. So this is a Node-RED instance running on a Raspberry Pi that we have in the office. So I'm going to now use this to post some data to my MQTT broker. So let me just quickly delete some of these, grab a node. So this is an example of another device sending the topic, and then we'll be able to see the WiPy also receive the message that was sent from here. So this has got a injection just saying hello world. What this will do is send hello world to this MQTT broker, and we need to specify quickly which one we're using. So Adafruit on the topic bucknell/feeds/lights. And then we can run that instance. So that's deployed. So when we click hello world, oops, just got to connect these two nodes. This might be trying to connect. maybe I have the config set up incorrectly. Bear with me. Let me just change this back to Atom so you can't see my credentials. Okay, that's connected now. So let's go back to Chrome. Cool. So what this should be doing now is sending hello world to bucknell/feeds/lights, which, if you remember correctly, was what our WiPy is currently subscribed to. So if I send, if I inject hello world now, so that's been injected. We go back to Atom.
Oh yes, hello.
And we. Oh, hang on. I think it's disconnected. So we're having some issues connected to it. Give me a second.
I'm just uploading it onto our accounting system. I think it's either been paid or being paid today. Is that what you're after, Ruth? Yes. Fred's out of the office, so I can't run it by him, but he's forwarded it to me to upload onto our accounting system.
For some reason, this is not working. Maybe this is to do with.
Yes, let me just take your contact number. I've got somebody on the documents, so I can take your contact details.
Okay, that looks better. So that's injected it, sent it to bucknell/feed/lights. We go back to Atom, and I show you that again. So you'll now see hello world has appeared. So this is what I sent through from a different device, not even a WiPy. It was a Raspberry Pi running Node-RED. I injected a string hello world, and then we subscribed to that topic on the WiPy, and it received that message. So it's a bidirectional protocol. You can both send and receive messages at a pretty fast rate, to be honest. So if I spam through, clicking loads of times, sending hello world a ton of times, we should see a bunch of hello worlds appear. So yeah, so let's grab all the messages on there. And that's gone from my Raspberry Pi up to Adafruit, back down to the WiPy, because we've subscribed to a specific topic. So you can imagine this could be used for a whole different variety of use cases. Oh, got a question here. Does it use HTTPS? Yes, so you can specify whether you want it to be encrypted. If you want to use SSL for your sockets, you can specify that within the library. Let me jump into the library and show you those settings. Here we go. Let me just close this quickly. So yes, you can specify if it's using SSL, which is your HTTPS encrypted sockets. And then you can specify your SSL parameters. So for example, if you wanted to use client certificates, you can specify them within the SSL parameters. And you can do a whole range of other encryption methods. The one thing I will warn about is if you're using the Mqtt broker, that is public. So if you want to send anything confidential over that, I would suggest you don't, because everything that goes onto there is probably being sniffed by some bot or something scraping all the messages. So it's not a secure MQTT broker. Adafruit, however, is, because you're using your API key to connect to it. But I would also ensure that you use their encrypted their encrypted socket, which, if you go to their let me navigate there. If you go to io.adafruit.com, you'll be able to find settings for all of their endpoints under their settings. So if you're just starting out with MQTT, I would recommend io.adafruit.com. It's really, really easy to get started with this. And you can see the different settings specified under here. So you can view your, I don't know what IO key stands for. Assume it's Adafruit IO keys. And that's what you need to connect specifically to your specific account. And then there's also encrypted sockets as well. And you can find out more about that if you visit their webpage or their web application. So let me just check. So I've spoken about securing usernames and passwords. So currently you have to do it in your main.py or config files. At some point, the firmware will allow you to actually block anyone from being able to jump into your device and see these. If you want to make sure your traffic's encrypted, you need to use an encrypted socket. So if you're just using generally standard 1883 as your port, your traffic will be unencrypted, so just be aware of that. If you're using an encrypted socket, your password, your username will obviously be sent as encrypted data, so secured. Bandwidth, it's incredibly high bandwidth, incredibly low latency. I showed you an example using the Raspberry Pi. I don't have any example data from the WiPy, but maybe at some point I'll get around to collecting that. Regarding the retaining data after waking up from sleep. So yes, when you do a subscribe, you can actually retrieve the last message that was sent. So for example, you had 12 different devices monitoring a greenhouse with different sensors and different plants, and you had a central hub that went to sleep every hour, woke up and then checked the data that sensors had sent, and you wanted to see what the last message was, if there was an alert or a warning. What it would do is it would wake up, subscribe to that channel, or that topic even, and get the last message that was posted. So this could be like a warning or an alert and let you know that something had happened. You can't, I don't believe you can recall every single message that was sent whilst the device was asleep. So do be aware of that. I think it's the last message that was posted as opposed to all of the messages. Unless, of course, I think there's a flag that specifies that otherwise. Feel free to comment below and correct me if I'm wrong on that. But this is down to the specific flags you set for your broker, so you would need to have control of your broker if those flags aren't currently set. Then regarding the docs example we have, so yeah, the example we have on our documentation is currently out of date. This refers to an old Mqtt example grabbed from micropython.org, which isn't in line with our current version, and actually I should probably make a PR for that repo to update it, because I believe we have a slightly more advanced version than the one that's currently in the MicroPython repository. Let me quickly have a look for that. So yeah, this one I believe is out of date. So don't pay attention to this, and then shortly after I'll post an updated example. Yeah, so this refers to an out of date library. Any other questions in the chat? Nope. So let me have a look at the quick links I posted up to talk to you about. Oh yeah, that's the last point. Let's look at doing a local Mqtt server. So we've seen about using Adafruit's server, which is hosted obviously with Adafruit. We've seen about the test.mosquito.org for doing just really fast testing, seeing if it's working. That's free, open to anyone, so just be aware that you're sending data that's not confidential. And now we'll look at doing an Mqtt local server. So let me quickly add my terminal to the input sources, and we'll have a look at doing that here. So what is this called? Terminal. Okay, there we go. Okay. Okay, so that should be on there now. So let me just full screen that. No, how's the best way of doing this? Let's make it a bit bigger. Okay, there we go. So clear this quickly. So what I've been using for doing local Mqtt servers with is actually the Mosquito variant of the Mqtt broker. So to get this on Mac at least, I use Homebrew for installing a lot of my packages. There's different installers for other platforms. I'll get them up in a second. Install Mosquito broker. I'll post this link as well in the forum when I'm done. I'm trying to remember all the links I've said I'll post. If you comment below if I've missed anything, let me know. I'll post them afterwards. So yeah, downloads, mosquito.org/downloads is where you can grab it from. Let me get that up quickly. Let's bring Chrome to the front. Okay, so yeah, so you can install it from mosquito.org/downloads. There's the Windows version, the Mac version, Linux versions for different variants of Linux, CentOS, Debian, Fedora. Whatever you need is here. I'm going to show you quickly how to do it with Brew on a Mac. That's my preferred operating system. So you can type brew install Mosquito. I already have this installed, so this will probably fail. There's a quick update of Homebrew while searching for packages, and then I'll show you how to fire that up and start sending messages locally. So the idea for this is if you want to send anything over your own network and you want to make sure that everything you're doing is staying locally, then you can set up an instance running on your own machine where you've got a server running in the background of a specific port. Cool. Someone's asked when the Pymaker plugin released. So while waiting for this update, I'll quickly answer this question. So the Pymaker plugin is actually out now. If you head to, let's put this in the background while we're talking about Pymaker. If you head to the forum, you'll see that Ralph, who's been hard at work on this, has released the plugin earlier today. He's done a nice overview of how it works and how to get started with it. And see in just a second when this loads up. Still waiting for Mqtt to update. Sorry, to Homebrew to update and install Mqtt. So I'll get back to that when it finishes. So if you head to announcements and news, you will see Ralph has posted the Pymaker plugin has released. You can read about here what he's been doing with that. And also, if you want to install it, you just open up Atom, go to File, then Preferences, and then go to Install Packages, search Pymaker, and it should appear. So Ralph has the instructions how to do this as well. It's also on our documentation, so you can get hold of that for when you need it. Let's jump back into Terminal. For some reason, it seems to be taking ages to update Homebrew, so I'm just going to cancel that, or try to cancel it, and show you it installed. If you just type brew install Mqtt, it'll do everything for you. So let's fire that up. I can never know how to spell Mqtt. There we go, fire that up. Okay, so it looks like we've already got something running on that port, so I'll just fire it up with a different port. So this might be the case on your machine. You might have something running in the background. I don't know what I have running on that port. Probably something important that I've forgotten about, some application or some process, but we'll set it on A4. So there we go, we fired up Mqtt. So it's as simple as that. You just type Mqtt-P, set the port, and then specify your port. So now we've got the socket listening on port 1884. Now let's jump back into Atom and have a look at how we set that up. So if we quickly just comment that out, open that up, and so I'm going to need now my computer's, my Mac's IP address to be able to connect to. Quickly change the port to 4. If we head back to Terminal, quickly open a new tab in there. I need to quickly get the IP address of my machine, so I can type if.config. This will depend on what machine you're using. I'm on a Mac, so if config works here, I believe on Windows it's ip.config, or ipconfig even. And you can see my IP address is here. So I quickly get that, jump back into Atom, hide that, so specify that here. And then I don't have anything set explicitly for usernames and passwords, so that should just connect. So let's try that. Okay, so that should be connected. Let me just send that around again. Okay. So just restarted that quickly. Connects to my office network. Joins the IP address. Okay, cool. So let's break out of that loop. Let's go to sleep. Okay, so it's breaking out of that. So let's pick this up again. Seems to be having issues. Okay, to the device. Okay, I think it maybe have happened when I disconnected it and reconnected it again. Let me quickly just restart Atom. and see if it appears then. Okay. Fire Atom back up again. Let's quickly go to Chrome. Okay, just relaunching Atom, give me a second. And then we'll run the new new local code on our local MQTT broker. Okay, so that seems to be working properly now. So let's quickly add that back to the YouTube so everyone else can see. Windows Capture, Atom. Okay, and then go back to Atom again. Nice. Okay, so that's way too big and blocking my face as well. Let me just resize that and bring that on screen. Almost there. Okay, perfect. So let me quickly open up that project. Cool. Oh, let's open another instance. Let's stay in this one. Add project folder. Quickly navigate through all of my settings to find the project. Give me a second. Okay, perfect. So let's go to main. So this has the server settings specified before, and then we can just run this code and it should connect to the broker. So yeah, fantastic. It jumps straight into our broker connected, publish a message, and then if we jump back over to our terminal, bring that up on top, you should see that a new client connected under the name WiPy from the IP address 192.168.1.85, which is the IP address of the WiPy, on the port 1884, and so now it's now connected. So when this published its message that obviously appeared on here, you won't see this because the server's not showing you any of the output from any of the topics. I think you can specify in the debug to actually show that, but it's not required. So yeah, so you can obviously then connect to this broker through anything else you want, whether this is your Raspberry Pi running Node-RED, whether it's your WiPy, it's connected over your Wi-Fi. Any means that you can connect to an MQTT broker, you can do that. And just to clarify as well, this works on not just the WiPy, it also works on the LowPi and the SciPi, so all of the boards that have Wi-Fi and Bluetooth, which is all of the Pycom boards. Sorry, you don't need Bluetooth, just Wi-Fi. They'll all be able to do MQTT, and they can all do the same connection methodology that we've been looking at today. So I think this pretty much covers everything that the community was asking for. If you've got any other queries and questions, do let me know. I'm happy to take anything now in the live chat, but again, I know a lot of people watch this after I've live streamed and put it up. So if you want to ask more questions, do feel free to keep commenting in that forum thread. I should really link the forum thread to the bottom of this video as well, so people can find their way back to it. So the next live stream we'll be doing will be in... Oh, okay. Do we have any experience tunneling HTTP to HTTPS with the use of Node-RED? So I haven't personally tried this with Node-RED. I think it should be pretty simple. When you jump into Node-RED, you can specify the connection settings of your broker. Let's do that actually now, because that's pretty simple. We can have a look at that. That's oh, not my emails. Let's have a look at that now. So let's jump into my Node-RED instance again, and let's create a new MQTT link. So we can jump into that, and then we can, oh, no, don't want that. Let's create a new one. So add a new broker. Look at the settings for this. So you can see you can add using Apache and Let's Encrypt. Okay, I don't have any experience using Apache and Let's Encrypt, but I'm sure that it will be very similar. So for the MQTT config and Node-RED, you can specify the server in here. So for example, our local one would have been, well, my local address is 192.168.1.65. And then if you want to enable SSL, you can tick the box. You can add your config for TLS, add your certificates. There seems to be a lot of comprehensive settings for doing this. You can set your TLS config there. You can also specify your username and password. And then also here you have the ability to set birth messages and will messages. So that is the message it will send when it connects to the topic, and also the message it will send when it disconnects from the topic. Cool. I hope that answers your question. I'm sorry I don't have experience with Apache, so I'm not sure exactly how that would work, but I will have a look into that for you and see what I can come up with. But yeah, so the next live stream will be in 2 weeks' time, and we'll be looking at actually no. So next week, the next topic we'll be doing is actually going to get some members of the community together to have a chat about some of their projects and what they're doing. So it's going to be a bit of a different, a bit of a variation on what we've been doing previously, where we've been looking at examples and running through kind of how-tos. We'll be going back to that after the next live stream, but what we're going to do is probably a Google Hangout, invite some of the community members to join and discuss what they've been working on. I know there's some really interesting projects going on, a lot of people posting what they've been working on and what they've been doing. So it's going to be a really nice opportunity to chat with the community about what they're doing. If that sounds interesting to you and you would like to get involved and actually jump on a live stream with me and have a chat about what you're doing, where we're going, also to discuss possibly the next couple of months with Pycom and what's in line for us, do comment below and I'll try to pick a handful of people at random to jump into a chat with me as well. Probably invite some of the moderators on the Pycom forums, as they've been doing a really great job of cleaning up and ensuring that your questions are answered. So unless anyone else has any questions for me now, I'm going to sign off for this week and see you again in 2 weeks' time, where we have our hangout and our chat with the community to see what they're working on. Okay, so I will see you in 2 weeks.